So with today, we are on day 3. Today we're going to deal with fractional. Today we're going to deal with fractional exponents with the exponent rules. So in a sense of the imagination, there's no real new learning today. You've spent the last 2 days working on the exponent rules. Today, the only difference is now instead of having whole numbers like yesterday and the day before, you had whole numbers as your exponents. Now we're going to have fractional exponents. So you're going to have to deal with adding and subtracting fractions, multiplying fractions, and doing all those types of things. The process that we did yesterday and the day before, the rules that we talked about yesterday and the day before, those rules don't change. The hardest part about this is fractions and being able to add and subtract and multiply fractions, which tends to be something that you guys struggle with. But the operations themselves do not change. So we're going to start out by going over the rules again, just making sure that you understand those rules. And then we're just going to look at several examples today that have fractions as their exponents. So we'll start out with just the product rule. We talked about the product rule, or you watched the video on the product rule on Tuesday, I guess. But product rule essentially talks about product in mathematics means to multiply, guys. Guys, this tends to be one of the more frustrating lessons that we do because of the fractions. So it's not that it's more difficult, it's just because fractions are involved. People think it is difficult. The product rule doesn't change. When the product rule, you multiply your coefficients. You multiply your numbers. So in this case, I've got 3. My other one after my times symbol doesn't have a coefficient that goes with it. So I'm just going to make it 3. Now we look at each of our bases. I've got a base of y in our first term. I'm going to just go ahead and highlight the first one. There's the first one. Highlight the second one and a second one so you know which of the terms I'm talking about. I've got a y in the first term and I've got a y in the second term. So we've got things that we need to multiply together. So the base, when we multiply, the base remains the same. The base is just going to be y. Now we take their exponents of that base and we add them together. So the base of the one in the pink is 1/3. The base of the one in the yellow is 4/3. Now, just underneath it, I'm going to go ahead and just kind of keep moving with it. 1/3 plus 4/3. Remember, when you add fractions, you have to have a common denominator. Once you have that common denominator, you just perform the operation. So 1 plus 4 is 5. You leave your denominator the same. So our denominator is 3. So we've got y to the 5/3. We've got the y value taken care of. Now we look at the x. We've got x in both the pink and in the yellow. So since we have it in both the pink and the yellow, we're going to go 3/2 plus 5/4. Well, they have different denominators now, so we're going to kind of do it off to the side. I've got 3/2 plus 5/4. What's my common denominator? 4 is our common denominator. 4 times what is 2? 2, so I have to multiply both the numerator and the denominator by 2. So 6/4 is the equivalent ratio to 3/2. 5/4, I don't need to do anything. My x value then, add the numerators, is 11. The denominator stays the same. That's our solution, and that's the product rule. Product rule means you add the exponents. They just happen to be fractions now. You perform the operations within there. And for today, we're just leaving it like this. We're not going to fix this. There's ways it could be fixed. We're not going to do that today. Questions with the product rule? Quotient rule. Quotient in mathematics means to divide. The quotient rule for the coefficients, do the same thing you always do with the numbers. You reduce the fraction. Give you a couple seconds to write this down. My plan today was to have guided notes for you guys because this stuff's a pain to write down. I ended up subbing last hour and didn't have time to put it together, so I apologize. Makes more writing than necessary. I know. I'm going to try to get better about giving you guys maybe not guided notes, but guided practice problems, so you don't have to sit and copy them down all the time. So my numerator is just going to be 2. There's nothing in the denominator, so we're not worried about it. We subtract. So I've got my x base in both the numerator and the denominator. I've got 2, but now we subtract. So it's going to be 2 minus 3/4. Okay, so let's deal with that, kind of off to the side. 2 minus 3/4, common denominator is 4. What do I have to do? The denominator underneath there is 1, so I have to multiply the numerator by 4. 4 times 2 is 8. So 8/4 is the equivalent ratio to 2 over 1. The other one's already. Subtract, we get x to the 5/4. X to the 5/4. And now we take care of the y's. The y's, we have 7/4. We have to subtract what from 7/4? 3 over 2. It's the exponent of my denominator's y base. So that's going to be 7/4 minus 3/2. Common denominator is 4 again. What's the equivalent ratio to 3/2? 6 over 4? Yep. 6 over 4 and 3/2 are equivalent ratios. That gives me what? Y to the 1/4. Do I have anything in the denominator? Nothing in the denominator. That's good. Next thing I look for is I look to make sure that my exponents are both positive. 5/4 is positive, 1/4 is positive. We're good to go. That's your answer and you're done. Quotient rule. You subtract and then make sure that you have positive exponents. Questions with the quotient rule other than adding and subtracting fractions? Power rule or power of a power rule. Power of a power rule says that first and foremost you have to distribute your of a power. The power has to be distributed to each and every single base. So if there were a coefficient out front, a number out front, the 4/3 would have to go to that number as well. There's not a number, so we don't have to worry about it. However, with this, we've got 2 different bases. We've got a base of x and we've got a base of y. That 4/3 needs to be distributed to each of those pieces. And when we distribute going to a power, you multiply. So my x has a base of 1/3, a power of 1/3, exponent of 1/3. I have to multiply it by my new power, which is 4/3. Multiplying fractions is no problem. Take the top times the top and the bottom times the bottom. Mr. Koob, that was his saying in 7th grade. I'm 40 years past that. I still remember Mr. Koob saying that over and over again in 7th grade. Top times the top is 4, bottom times the bottom is 9. So I've got x to the 4/9. My y variable has an exponent of 1/4. I need to take that times 4/3 as well. Multiplying fractions is no problem. Take the top times the top, bottom times the bottom, and then obviously this gives us 4/12. You should reduce the ratio if you can. 4/9 cannot be reduced. Why? What goes into both 4 and 12? So 1/3. We can't combine those two things because they're different bases. We're done. They're both positive. We're in good shape. We've done what we need to do. Questions with the power of power rule. Okay, to kind of recap this page real quick. Product rule. What do we do with the product rule with the exponents? Everybody, what do we do with exponents? Multiply, we add. Everybody, divide, we subtract. When we go to a power, we distribute, and then what do we do with the exponents? What do we do? Top times the Mr. Coop. Book backwards. Man was absolutely. So we had a super heavyweight wrestler. Back to the story about Mr. Coop. Sorry, Mr. Coop was this. Not fat. He was a big guy. He was stronger than heck. We had in Iowa back then they had what they called a super heavyweight. We had a super heavyweight guy that there was no weight limit to this. This guy probably weighed close to 350 pounds. Mr. Coob probably weighed 225, but was a solid brick. They would wrestle in the wrestling room. It was just hilarious. As soon as the big guy got on top of Mr. Coob, he was done, but they could never take him down. It was just cool. Anyway, so let's put them together where we have a bunch of things going on, maybe and maybe not. So let's look at this first example. We've got x to the 3/2, y to the 2nd, times x to the 1/3, y to the 7/4. Somebody walk me through it. What are we going to do? Add what? Okay, so my x is my base. What are my two that go with it? 1/3 and 3/2. So we've got 3/2 plus 1/3. Everybody okay with that setup? Okay, we'll get back to it in a second. Y. What am I going to add together? 2 plus 7/4. Sidetrack. 3/2 plus 1/3. Common denominator. 6. 3/2 is the same thing as what over 6? 2 times what is 6? 3? 3 times 3 is 9. So 9/6 is the same thing as 3/2. What over 6 is the same thing as 1/3? 2. So that gives us x to the 11/6. 9 plus 2 is 11. Y to the 2 plus 7/4. Common denominator is 4, right? So 8/4 plus 7/4, which is 15/4. Everybody good with that one? Operation-wise, do we see what we do? Adding the fractions. We've been adding fractions for a long time. There's an ABC button on your calculator.
Can you do how you get 15 again?
8 plus 7. Just add the numerators and then leave the denominator the same. Okay. So we got the second one. So we got 3. X to the 3/2, y to the 7/4. Over 2, x to the 5/2, y to the negative 5/4. Number-wise. What number do I have in my numerator at the finished product? 3. 3. What number do I have in my denominator as a finished product? 2. They don't reduce in any such way. So we're good. So I'm going to put the x on the top. It's just easier sometimes to do it on the top. So what am I going to do with the 3 halves and the 5 halves? Add them or subtract them? Subtract them. So that's 3 halves minus 5 halves. We'll put that down here. So that's 3x. 3 halves minus 5 halves is negative 2 over 2, which is just negative 1, right? Okay, so we got another one down here. We got to even take it further. We got a big chain of things going on here. Y's. Y's, I've got 7/4 minus negative 5/4. Remember, we're subtracting. Even though that's negative, we still subtract. Subtract a negative, then it really just becomes 7 minus negative 5. So 7 plus 5 is 12 over 4. Again, negative 7. 7 minus negative 5 is 12. 12 over 4 is just 3 over 1. So we can just put it that. So we've got this going on. Can we leave it like this? Okay, we've got the negative, x to the negative first. Remember, negative exponents. We just move it to the other piece. Since it was in the numerator, we drop it down to the denominator and make it positive. And we talked about the y for that yesterday. It's just kind of the cheat code to it. Okay? We okay with that one? All right, let's skip to these. So when there's a single operation, when you just have to do one thing, when you just have to multiply, or you just have to divide, or just you have to go to a power, those aren't too bad. You just have to remember if you're multiplying, to add. If you're dividing, you subtract. If you're going to a power, you multiply. And again, all of those exponents. Well, when you have two things going on, first and foremost, my suggestion to you is take 2 seconds to figure out what the heck is going on. Just don't write and start. Talk yourself through what's going on with this. I've got y that's risen to the 7/2 power that's being divided by y to the 3/2 times 4y to the negative 5/2. So I've got one thing, for lack of a better word, there's probably a better word, I just don't know what it is. I've got one thing in my numerator. I've got two different things. I've got an operation going on in my denominator. I don't want any operations going on in my denominator. I want one thing over one thing. So the first thing I need to take care of is making this one thing. Again, bad mathematical terminology, but I don't care. So we need to make that denominator one thing. So my numerator is staying the same for now. It's staying y over 7/2. My denominator, now I have to multiply. So I got to think about my multiplication rules. 4 times 1 is still just 4. I've got y as basis for both of them. What do I do with the exponents when I multiply? We add. So that's 3/2 plus negative 5/2. Okay. In the numerator, I haven't changed it. It's still y to the 7/2 over 4. They have a common denominator, so I don't need to do anything to the side. I've got 3 plus negative 5 because I can read my own handwriting. 3 plus negative 5 is negative 2. I just forgot to put the y there. So I've got 4y to the negative 2 over 2. Does that look right? Now the question, should I reduce it? Why not? Yeah, don't reduce it. I already have it. Good job. I already have it. So it doesn't make any sense to reduce it because then I'm just going to put it back anyway. So now we deal with the division. When you divide, you subtract. So that's going to be y to the 7 halves minus negative 2 over 2. All of that over 4. 7 minus negative 2 is? 7 minus negative 2 is? Thank you. 9 over 2. We're subtracting. The denominator stays the same. 7 minus negative 2 is 9. There's your solution. We've got it cut down to one thing, over one thing. Okay. Questions with that one? Okay. Next one. Got a couple more that we're going to do. Actually, 2 more that we're going to do. Give you a couple seconds to write this down.
I was down in the IMC for
Of all things. All right, so let's walk ourselves through it. Some of you, if you're good to go and you want to try it on your own, just go. For those of you that are still having some questions, let's kind of walk ourselves through it again. So mathematically, I've got a base, 2 bases, x and y. They're being risen to a power. So this is essentially one thing. And I've got another going on. So we have to take care of powers first. So we have to do this risen to the 3 halves first. So that's the first thing. And then I can multiply it by x to the 1/4, 7/8. So I'm going power to power. So what do I do with the exponents? What do I do with the exponents when I'm going power to power in this part right here? Multiply them. So I'm going to have x to the negative 3 halves times what? 3 halves. Which we're just going to go do that. That's x to the top times the top. Negative 9, bottom times the bottom. It's 4. Now we've got y. Its exponent is 7/4. I need to multiply that by 3 halves. Top times the top is 21. Bottom times the bottom is 8. Okay, so I'm just going to kind of highlight this. So this piece of this is right here. I still haven't dealt with this. So I still have to take this times with a x to the 1/4, y to the 7/8. So I've got one thing and one thing. So I've got a multiplication symbol between them. I've got 2 bases. What am I going to do with the bases when you multiply? What are you going to do with the exponents when you multiply? Add them. So negative 9/4. Negative 9/4 plus 1/4. Negative 9/4 plus 1/4 is negative. Let's just do it on the side. Negative 9/4 plus 1/4 is negative 8/4. Negative 9 plus 1 is negative 8. So that's negative 8/4, which becomes negative 2. Does everybody see how I did that? Negative 9 plus 1 I just did over on the side over here. Got negative 2. My y's is going to be 21/8 plus 7/8. Again, we'll just do it off onto the side. 21/8 plus 7/8, 28/8. Add the numerators, leave the denominator the same. They're both divisible by 2 or 4, right? Divisible by 4. 4 goes into 28 7 times and into 8 twice. Are we good leaving it like that?
Wait, wasn't it negative? No.
Nope.
X negative. So it'd just be
Y to the 7 halves over
X squared.
x squared. Okay. All right. Last one we're going to do. I'm going to have you go ahead and work with a partner or by yourself. Don't really care. Talk yourself through question number 8. See what you get. Give a little hint. Take care of the reducing on the inside of the parentheses first. Reduce first, then do the fraction. Then do the power. 5 minutes, go. You shouldn't need 5, but let's say 7. 5 is more than 7. 7 is more than 5. So if it shouldn't take you 5, it really shouldn't take you 7. So let's go 3.5. Okay. Just do it. Again, reduce this first by subtracting your exponents, and then do the power. There's a lot going on in there. And it's all fractions. It makes it look uglier, doesn't it?
Yeah. It looks scary.
It does look scary. A lot of difference. Although, I mean, they're kind of nice. I mean, we are kind of nice. The denominators are the same, so you don't have to worry about that.
What's that? Huh? Hey, where's that? Oh. I was surprised by getting minutes. Start on Rusty. Makes it. Makes the difference between me and you. So, I'm just more of a person.
Does that look right? Does that look right? Does that look right? Does that look right? Right, but does this part, did you get to this part? Right. Yeah, there's another step.
What threes? Oh, is it fine if you still put king one?
What's that?
Is it so fine if you put y one? Great, great. I don't know what it's called.
Okay, let's take a peek at it, see how you did. So I'm going to take care of the inside first. We're dividing, so we subtract. Shh, guys. Last one, guys. So we've got 5/4 minus negative 3/4. When you do all that, again, it kind of did the math on the side. You get x squared. And then we've got negative 5/3 minus 7/3. When you do that, you end up with 2/3. So first step, x squared, y to the 2/3, then risen to the negative 3/2 power. Now power to power, you multiply. So we're going to take 2 times negative 3/2. 2 times negative 3/2 is negative 3. So that gives us x to the negative 3. 2/3 times negative 3/2 is negative 1. So y to the negative 1. Remember, I can't see that down there. I can't really pull it up any higher. We don't like to have negative exponents, so they were in the numerator. Make them positive to the denominator. The question was asked, is it okay if you still put a 1 there? Of course it is. Would not be anything different. Okay. So the complexity of these for today. You need to remember the basic rules. The product rule says that you add your exponents. The quotient rule says that you subtract your exponents, and the power of power says you multiply your exponents. Keep those in mind. Second thing you want to make sure that you do, if you have a bunch of operations going on and you're dividing, get to one operation on both the numerator and denominator. If you have powers, do all of those things. Biggest thing with this, with the fractions, take your time. I always do the fractions kind of off to the side. It just makes it easier for me. Doing this part of it and writing this out seems to help because you see what's going on. Also for me, when I'm correcting these, I can see if you have this right, at least I know that you have the quotient rule taken care of. And I know you have the power of power rule taken care of. You might not be able to add fractions or multiply fractions, but I at least know you know how to do the higher algebra stuff. Then I can just work on you doing fractions. We can sit here and do time tests with fractions. Wouldn't that be fun? Okay, maybe not. I got 0 reactions. I'm done for today. The worksheet is in there. Just do the evens. If you've done it all, do it all. If not, just do the evens. Tomorrow we're on to a different day, and I bet it deals with fractions as well.